Okay. I'm going to be working through the Geometry K final review. The good news that I'll go ahead and let you know is that this review is very similar to what you're going to see for the test. It's almost problem for problem. You're going to see a similar problem like these, like each one on the test. So let's start with number 1. It says reflect the image over the y equals x line. List the coordinates of 3 points that lie on the reflected image. So if you're reflecting over the y equals x line, the rule for what you should do with the coordinates is y comma x, meaning that let's pick 3 points. Okay. So let's do this point, this point, and this one. So this point is at -1, 1, 2, 3, 4, 5, 6. This one's at, let's see, 1, 2, 3, 3, 6. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So -7, 3. Okay. All right, and for each point, you're going to switch the coordinates. So it's going to become 6, -1, 6, -3, 3, -7. Okay. All right, number 2. In the graph below, segment AB was rotated 90 degrees counterclockwise to create segment AD. List the 2 other transformations that would be needed to create a square, and be specific. How many degrees, which direction? Okay, so if I'm going to make a square, then my other 2 sides need to be here and here. So it's asking which 2 transformations will make this line go here and here. So the first transformation, if it rotates 90 to make this line, then we could rotate 90 in the other direction. So this went counterclockwise. Let's rotate clockwise to make this segment. Okay. And then for the top one, if we took this and moved it up, then that would create this top bar. So if we translate this up 1, 2, 3, 4, 5, up 5 units. Okay, that would create the top of the square. All right, number 3. What counterclockwise rotation produces the same image as a clockwise rotation? Counterclockwise and clockwise make a full circle, which is 360 degrees. So if you want to know its other part, 360 minus 205 gives you 155. Okay. List the equations for 3 lines of symmetry of the hexagon shown. Okay. So the lines of symmetry that I see, use a highlighter. Okay. We could say that the y-axis is a line of symmetry. The x-axis is a line of symmetry. If we went diagonally, that's a line of symmetry, and diagonally the other way. So really there's 4 lines of symmetry here. The thing is, it wants these equations for this line. So that doesn't mean it's not going to say y-axis on the test. It's going to say, hold on. Okay, so y-axis. So the equation for the y-axis is actually the equation x is equal to 0. Remember that x equals creates a vertical line, and this is where x is always 0. So that's your equation. Okay. The x-axis, on the other hand, is the other one. It's the y equals 0 line. So y equals equations are horizontal, okay, and that's the y equals 0 line. These diagonal lines, so the diagonal line that's going positive up as a positive slope going through the center. That is the y equals x line. Okay? And on the other hand, the line that is the negative one, okay, so this has a negative slope, so this is the y equals negative x line. Okay? All right, next. Write the rule for the translation from point R to point B. So point R is at -3, -4, right? -3, -4, okay. And we want to take that and translate it to point B. So here's point B. So translation is just a movement. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going 10 to the right. So we're going to write that as x plus 10 units. Okay, and then we're going up 1, 2, 3, 4, 5, 6. And then we're going up 6. So that's written as y plus 6. Okay, this is referring to the same picture. Point P is transformed to using the rule -x, y minus 10, which point describes the new transformation. So this rule right here, okay, is multiple transformations. So if you look at your rules, I've showed this to most of my classes. So here's your rules for translations. If it's x, that's moving left or right. Left is subtracting, right is adding. For y, that's moving up and down. Subtracting is down, adding is up. These are your reflection rules. The x-axis is x negative y. The y-axis is negative xy. These are y equals x and y equals negative x. And here are your rotation rules. So if x has a negative in front of it, but y is positive, that means that this is a reflection over the y-axis. Okay. Negative x, positive y. That's a reflection over the y-axis. Okay. Okay. So then that's the first transformation that happens here. The second one is that it goes down 10 units. Okay. So we need to take point P and do these two transformations. So here's point P at, let's see, we've got 1, 2, oh wait, sorry, no, that's -7, 2. Okay, so a reflection over the over the y-axis is going to make this x change sign. So that means that it's going to go from a -7 to a +7. Remember, the negative doesn't mean make it negative. It means change whatever it is to the opposite. And then we're going to go down 10 units. So 2 minus 10 would be -8. Okay, so this is our new point. So 7, -8 is at point C. All right, next page. I'm not going to linger very long on these questions like I normally do. We've got a lot to get through, so if you need a little bit more time to process a question, just pause the video and you can look at my work, okay? But I'm going to keep moving to save some time. Okay. So the dilation rule xy, this is the dilation rule xy to 0.99x, 0.99y. So these two numbers right here, this is the scale factor for this dilation. Okay. If your scale factor is less than 1, that means that this is a reduction in size. It gets smaller. Okay, so the answer would be B. If it's greater than 1, okay, that would be an enlargement. Number 8, describe the two transformations that were used to create quad A prime, B prime from this original one. Okay, so if you'll notice, first of all, this turned on its side, okay? So turning on its side would be a 90-degree rotation, okay? So you could think like we would take point A, 90-degree rotation, the rule is negative y, comma x. So like A is at 3, 4, that would become negative 4, 3. Okay, and then we can make the rest of it from there, because so this would be A, this would be B. Let's see, D is at 2, 1, so that would become negative 1, 2. Okay, so there's D, and then there's 3 in between them, so 1, 2, 3, so there's C. Okay, that's the 90-degree rotation. Now, after it rotates, you can see, notice how A is on bottom here and B is on top, and then it flips. A is on top, now B is on bottom. That's the signal that this was a reflection flipping over and not just a translation, like moving it down. Because if we just moved it down, A and B would be in the same place. But because they switched, it flipped over. So this is a rotation of 90 degrees. And then a reflection, and this is flipping over the x-axis. Okay. Next question, we are reducing the square root of 120. So, for these kinds of problems, what you're going to do, I'm just going to be showing the calculator trick and not the long method. If you want the long method, go look at one of my other videos earlier in the year. But at this point, we're just trying to get through. So, reduce the square root of 120. So the calculator trick is to go to your y equals, type in 120, and divide it by x squared. The idea behind this is that we're looking for perfect square factors of 120. Okay, once you're in your table, you're going to scroll down, and you're looking for the last whole number that was in the y column. So once you get to here, like where it's becoming all decimals and they're just getting smaller, you've gone too far. Okay, they're just going to keep getting smaller and smaller decimals. So scroll back up. This was the last whole number in the y column. So the pair is 2 and 30. When you have that, 2 is going to go outside the square root. 30 goes in the square root. That's your reduced square root. Okay. All right. Next, classify the triangle to the right. So, if a squared plus b squared equals c squared, that's a right triangle. If this is bigger than c squared, that's an acute triangle. But if it's smaller than c squared, that's an obtuse triangle. Okay, so we would do 7 squared plus 10 squared. That's equal to 149. 16 squared is equal to 256. C squared is bigger, so this is an obtuse triangle. All right. Next, Alice and Jordan want to get from point A to point D. Alice goes from point A to point B and then down to point D. Jordan goes straight across. How many more yards did Alice go than Jordan? Okay, so this is a two-step problem. Step 1, you need to use Pythagorean theorem to solve for this hypotenuse. So I would do the square root of 28 squared plus 21 squared. And that's equal to 35. Okay? But the question isn't asking for the hypotenuse, although I'll bet you that this is one of the answers on the test. Okay? That this would be an answer choice. But this is the wrong answer because you need to add these up. Okay, her distance, Alice's distance was 49. Okay, Jordan's distance was 35. So we need to subtract them. Okay, 49 minus 35 is 14. This is the correct answer. Number 12. The triangle shown below is isosceles. What is the length of its altitude A? Okay, so on the outside, this is a right isosceles triangle. Okay. So if this is 9, this is 9. Okay. And then the idea is that this here would be 9 square root 2 if you know your 45, 45, 90 rules. So this angle would be 45, this angle would be 45. Now, when you draw the altitude, notice that this is 90. And if this is 45, that means this would also be 45. So it creates another smaller isosceles right triangle inside of here. Okay. So this is also a 45, 45, 90 right here. But this time, okay, give me a second. Okay, so let's see. Did I pause on this? Okay. Okay, so then what was I saying? Okay, so this is a smaller 45, 45, 90 triangle. This side, this time, this is representing your x square root 2 rule. So we would say 9 is equal to x square root 2. You want to solve for x because these are our x sides. So I would divide by the square root of 2. Okay? So x is equal to 9 divided by the square root of 2. We can reduce this further, but I'm not going to bother with that because on the test, the answer choices are all going to be kind of weird. Like, you might have something like a 4 point, I don't know, actually. So, okay, so you would have something like a 4.5 square root 2. You would have a 9 square root 2. You'd have something like a 9 square root 5 or something like that. You could also potentially have things that are like the square root of 9 squared minus, I don't know, like 4 squared or something, or like the square root of 9 squared minus 4.5 square root 2 squared. Okay? So what I want you to do in these situations, instead of trying to simplify it the way that the test wants you to simplify, convert your answer to a decimal, and you can do that just by typing it into the calculator. So that's 6.36. Okay? And then convert all of your answer choices to decimals. So like if I did 9 square root 2, well, that's about 12.72, so I know that's not right. 9 square root 5 is about 20.12, 12.72, so that doesn't match what I got. Okay. If I do 4.5 square root 2, that matches 6.36. Okay. That means that if this were my answer choice, this would be my correct answer. I'm going to show you some of the others. Okay. So if I did 9 squared minus 4 squared, that's equal to about 8.06. So that's wrong. Okay. If you did the square root of 9 squared minus parentheses 4.5 square root 2 close parentheses squared, type it in exactly as it's written on the test. Notice this is also equal to 6.36. So if this were an answer choice, that would also be correct. Okay. Now, I'll just briefly explain why this is correct. If you know your tricks for these special rights, whenever the x square root 2 is a whole number, you can take this, divide by 2, and it's that square root 2. Okay, 4.5 square root 2. You could also think of it like this 9 square root 2 is getting cut in half. So that becomes 4.5 square root 2 and 4.5 square root 2. Now, the reason why it's written like this is because it's written as if you were putting things into the Pythagorean theorem. So you're taking the hypotenuse, which is 9, and subtracting this leg, which is 4.5 square root 2. Okay? And that gives you this hypotenuse here. All right, next question. So it says, given the square below, what is the value of a? And leave your answer as a decimal. That's important. In this problem, you're going to be adding and subtracting square roots that are different. You cannot do that as square roots. You have to convert them to decimals. Okay. This shape is a square. This is a 30, 60, 90 triangle. So following the 30, 60 rules, this side is 2x, this side is x, and this is x square root 3. It's based off of the angle it's across from. So across from 30 is x, across from 60 is x square root 3. On this triangle, it would be the other side. So this would be x, and this would be x square root 3. Okay, across from these angles. Okay, so if 2x is 8, that would mean x is 4, and this side is 4 square root 3. So this side would be 4 square root 3. Okay, this is a square, meaning that if this side is 4 square root 3, so is that side 4 square root 3. Okay, all right. If you take this length of 4 square root 3 and you subtract that length of 4, you're going to be left with a, which is what you want. So we would do 4 square root 3 minus 4. It is not square root 3. That is not your answer. You need to convert your answer to a decimal. Get your decimal, subtract 4. Your answer is 2.93. And I'm just going to prove it to you. The square root of 3 is 1.73. So this is not the correct answer. This is your correct answer. Okay. What is the perimeter of the triangle? This is another 30, 60, 90 in disguise. You've got 90. This is A. This is 2A. That means that this would be 30, and this would be double 30, which is 60. Okay? So, using your rules, this is your x side. This is your x square root 3 side, so that would become 9 square root 3. This is your 2x side, so 9 times 2 would be 18. You add them up. 9 square root 3 plus 9 plus 18. And again, adding these up, you need to convert to decimal. So 9 square root 3 plus 9 plus 18 is equal to 42.59. Okay. I want to point out that you could also use SOHCAHTOA in a problem like this. I'm not going to get into that right now because we're going to have other SOHCAHTOA problems, but just know that that's a possibility. Okay, I'm going to stop the video here just because for the sake of time. We're getting at 25 minutes here. So if you want to see me continue on to the next page, then go to the next video, and that will continue there.